Here are the answers to Component 3 AMC Lesson 2 on break-even. Here's your first answer to question 1, where Lucy's started to construct the break-even chart and your job was to move the boxes to the right, the labels to right boxes. So the first one was done for you in the lesson. Here are the answers. Here are the answers to questions 2, 3 and 4 with Tyler and his photography business. And we're looking at 3 questions on this slide. The area in the red, question 2, is where the company's making a loss. The area in green, which is labelled Y, represents where Tyler is making a profit. And question 4, identify what the area labelled Z represents. Well, the area labelled Z is actually just a straight line, and the straight line represents fixed costs. The answer to 5A, which is Jasmina wants to calculate the number of domestic jobs that she needs to take on break even, well, we don't actually need all of that information because the question is saying what is the formula to calculate revenue. The formula is price times quantity sold equals revenue. First of all, let's make sure we've labelled the x-axis, that is output, and the y-axis is cost, it's pounds, and this time it's cost and revenue. The green line, fixed cost, which is fixed at 4,000. Next, let's take on the red, the total cost, and as you can see it starts at 4,000, which is where the fixed cost line is. And then what I recommend you next do is plot each of the numbers, so watch where the x's come in. You've now got 5 points on the chart, that's because you also have the 4,000, the starting point, so it should be straightforward now to draw the line going across. Now let's take on the revenue line, the purple line. Now on this one, on the chart, on the 5A slide, you've actually got number of jobs and average revenue. That's because you need to look at the x-axis and the y-axis. So on the first number of jobs, you've got no jobs, no revenue. Guess what? You start at 0. Then the second column, you go along the x-axis to 100. Sorry, not y100, that's a bit bonkers. You go along the x-axis to 100, and you go up the y-axis because it says it's 3,000 in average revenue. So then you plot your first mark there. Let's do exactly the same for the third column. You go along the x-axis to 200 in terms of number of jobs, and you go up the y-axis until you can see 6,000 and plonk the x in there. The same goes for the final 2 x's. So let's put in the purple line. Here it goes. You will notice that the point at which it comes anywhere near the total cost line is actually at the end of the chart. That's fine as long as it is actually going to cross it. That is your break-even point. (6A) answers. This is about Lewis contemplating whether he can offer his early diner specials. So first of all, we need to complete the activity table below before we can even start to plot his finances onto the break-even chart. Let's look at the first column where there are no early diner specials sold. So you've made no sales and you've not had any variable costs, but you do have to pay £300 in fixed costs. So overall, 0 variable cost plus £300 fixed cost gives you a total of £300. Next, let's take a look at the middle column where we are selling 25 early diner specials. So 25 times £20 sales price gives us £500. 25 times the average variable cost of £10 gives us £250, fixed cost stays the same, and we need to calculate total costs, so we need to add together variable and fixed costs, giving us the answer £550. And finally, the last column, where we're making 50 of these early diner specials. 50 times £20 sales price gives us a revenue of £1,000. 50 multiplied by £10 gives, which is the variable cost, gives us a total variable cost of £500. Fixed cost does what it says, it's fixed at £300, so therefore our variable and fixed together gives us a total cost of £800. The first three boxes for Lewis's early diner were done for you, so here they are again. So too were the first of the X's to plot out the numbers on the chart, so here they are again. Here's fixed cost. Let's plot them in. It's at 25 early diners at £300 on the y-axis, and 50 early diners on the x-axis. On output is the same line across, so let's draw in our green line. Let's plot total cost then. It starts at the 300, remember, because that's where fixed costs were. So for 25 early diners, that's going to be at 550, and for 50 early diners, that's going to be £800. Let's complete the total cost line then, starting at the 300. Let's plot the final line, total revenue, the purple line. Let's put in the 2 marks at 25 early diners. That gives us revenue of £500, and at 50 early diners, that gives us revenue at £1,000. Here's the purple line drawn in from 0 early diners to 50 early diners. And the break-even point is here. It's actually where the purple and the red cross, which is at 30 early diners. Now, if you remember, the question actually says that Tyler thinks that he might have to sell 50 early diners. Now, by doing the break-even chart, he can actually see that he only needs to make 30 and then he starts to make profit. So this is the what if in action, and he's worked it out as slightly better for himself. For question 7a, we were looking at the family deals. We've got fixed cost £180, variable cost per family £6, and the actual sales price for the family deal is £15. On this first column, you can see here, you actually had 3 figures given to you, so the final figure, 0 plus 180, in order to get total cost is £180. In the middle column then, at 25 family deals, we've got 25 multiplied by £15, gives us a sales revenue of £375. Variable cost is 25 times £6, gives us £150. Fixed cost stays the same, so we need to add fixed and variable, so 150 plus 180 gives us £330 total costs. And the final column are 50 family deals. So you've got revenue of 50 times £15, so it's 750. Variable costs £300, which is £6 times 50. Fixed stays the same, so variable and fixed together gives you £480. Question 7b, where you are plotting the data from the TBP limited family deals that you've calculated on the last slide, and we're going to look at how to plot the data. First of all, we're going to mark on all the X's. Here are the 3 already given to you from the lesson. Let's plot the fixed cost at £180 as a straight line going across. So let's plot in the X's, and this is what the line looks like. Let's now plot the total costs. So let's put in the red marks. Here's the red line for total cost. Let's plot the final 2 figures for total revenue based on the family deals sales that we've calculated. with 25 family deals being sold and then 50 family deals being sold. Here's the total revenue line now plotted on the chart. So this would be break-even point. So if we look along the x-axis, the output, the number of products, that's actually 19 products to sell so that TBPs can break even on their family deal. And finally, if you remember the question, it said that the family thought they needed to spend, they needed to sell 60 family meals in order to break even. Well, they really needed to do this break-even analysis because they only need to sell 19 to break even. They make a profit a lot quicker than they thought. So 8A question is about you organising the difference between fixed cost and variable cost. Fixed costs are the costs that are indirect, they're not specific to the product. So of the 5 things in that list, there are 2 which are nothing to do with coffee. That's loan repayment and insurance, so that's in the blue box. And then you've been asked to create the total monthly figure, so you add them up. So that's £600. And the rest, the coffee, beans, milk, sugar, syrup and sundries, that goes in the orange box. And you've been asked to total the monthly variable cost, and that is £225. Question 8B, you've got Sita and Charlie forecast that up to 1,000 people a month will buy a cup of coffee at £2.20. They've given you some cost and revenue information to use to draw the break-even graph on 8C. You do need to complete the table, but you've only got fixed costs and total costs to deal with, so you've got a lot of numbers already sorted. So here are the numbers in the red box for you to sort. Please remember that if you don't have any graph paper, then use lined file paper for the horizontal lines and draw in some halfway ones if you can, and you can then draw in your vertical lines to actually make your X and Y axes. Or if you can, pause the video on this slide, print screen and print it so you can have access, if you have access to a printer. You've got 3 labels, the title, the X and the Y axis already given to you, and the first 3 plotted points on the graph already given to you. Here are the other points for fixed cost at £800, which makes your fixed cost line look like this. Your total cost points at £900 when producing 500 coffees, and £1,000 when producing 1,000 coffees would go here, and your total cost line would look like this. Your revenue at 500 coffees for £1,100 worth of sales would look like these. That's where the first one would be, and for £2,200, here we go, which gives you a purple total revenue line looking like this, which marks this spot as break even where the costs and revenue cross, which at my calculation says they break even selling 400 coffees. Question 9A. BTD Limited forecasts that at least 15 customers a month will use the proposed property management cleaning service. The business has given you some forecast costs and revenue information to use when drawing a break-even chart for its first month of operating the property management cleaning service. Fixed costs are £1,200 per month. Revenue is £180 each house, and variable costs are £30 each house. Your first job is to complete the table below so you've got an idea of the costs that you need to calculate and therefore plot on the chart on the next slide. In the first column for you to fill in, you've got no houses that were cleaned, so you've made no money, so you have no variable costs. You've been given fixed costs at £1,200, so you have to work out total costs. So 0 plus 1,200 equals 1,200. In the second column for you to fill in, which is 5 houses that were cleaned, that gives you a revenue of £900 and variable cost of £150. The fixed costs are the same, that's 1,200, so add variable and fixed together and you've got 1,350. On the third column for you to fill in, there are 10 houses that are cleaned, so that gives you a revenue of £1,800 as it's £180 per house. A variable cost of £300 because it's £30 per house. You've got fixed costs, which is £1,200, so fixed and variable together gives you a total of £1,500, £1,500. And the fourth and final column for you to fill in is 15 houses that are cleaned. 15 houses gives you a revenue of £2,700, variable cost of £450, and fixed cost again 1,200. So fixed and variable together gives you a total cost of 1,650. Well, for 9b, we've already got some information on the graph. We've got the green fixed costs, we've got the red total cost, we've got the purple revenue plotted on the chart, we've got output labelled on the x-axis, we've got cost labelled on the y-axis, and the title at the top, BTD Limited Cleaning Break-Even Chart. Your job, just as a little job left, is to plot the rest of the data onto the chart, and we can see what we can find out when we do this break-even. So here are the marked for fixed cost at 5 houses, 10 houses and 15 houses, giving a fixed cost line looking like this. Here are the points for total costs, so we've got an additional one at 5 houses, 1,350, 10 houses 1,500 and 15 houses 1,650, giving a total cost line looking like this. And here are the revenue numbers factored in. We've got £900 made after cleaning 5 houses, then £1,800 after cleaning 10 houses and £2,700 after cleaning 15 houses, which gives a revenue line looking like this. And this shows the break-even point here, and that equals 8 houses that need to be cleaned in order to break even. Here are the answers to classic waffles for 10A. The first column for you to fill in with no waffles sold, no sales revenue, so therefore there's no variable cost. You've just got fixed cost at £800, so your total costs are £800. Your 500 waffle column to fill in the middle. You've got 500 waffles sold at £2.20, giving you a revenue of 1,100. A variable cost, which is 50p per waffle, gives you a total of £250 for variable cost. Fixed cost is the same at 800, so variable plus fixed gives you a total of £1,050 for total cost. The final amount for classic waffles, making 1,000 waffles, you've got 1,000 waffles multiplied by £2.20, which is 2,200. You've got a variable cost of 50p for 1,000 waffles, which gives you a total variable cost of £500. Fixed cost stays the same at 800, so fixed plus variable gives you 1,300 as your total cost. The first 3 labels are given to you, so here's the title, the x-axis output and the y-axis cost for you. Here's the fixed cost mapped for you, and the red total costs and purple revenue as your starter figures mapped on the chart for you. Here are the fixed costs mapped onto the chart at £800, giving you a fixed cost line looking like this. Here are the total costs mapped onto the chart. We're looking at the 500 waffle sales. We're looking at putting in 1,050, and for 1,000 waffles we're looking at putting in 1,300. giving you a total cost line looking like this. And here are the final 2 marks on the chart. We're looking at revenue of 500 waffles at £1,100 and 1,000 waffles at £2,200, giving you a total revenue line looking like this, giving you a break even of 475 waffles based on the figures we've got. Well done, you've completed all the charts and break-even analysis for lesson 2 on component 3 AMC. Whey!